Hello, everyone. We would like to talk about our journey to ephemeral test environments with EKS and ArgoCD. My name is Tatiana.
And I'm Gazal. We both work for REA Group, a digital business headquartered in Melbourne, Australia, dedicated to changing the way the world experiences property. We also have an office in Cyber City, Gurugram.
Once upon a time, when systems were simple and we could test locally and call it a day, we could get away with it maybe 20, 30 years ago. However, even with the simple systems, we could get a memory leak and miss it. So we don't need to use test environments. We built test environment and ignored it. No monitoring, no alerts. And then it broke, and customers told us first. It could be a story familiar to many of us in this room, and I definitely saw it happening. So it's not enough to build test environment and let it be. So the next iteration is we build test environment, we look after it, we monitor it, but it drifts from production and it invalidates our tests. The next iteration is testing in production. And that was my experience when I joined REA platform team and started to work on custom operators for Kubernetes. Custom resource definitions, or CRDs, extends Kubernetes API, and functionally it means that you have a custom resources in your clusters now. So after experiencing drifting environments, our team decided, well, we don't want to have long-running test environment. Instead, we are going to test in production. We have used the next suffix for CRDs, effectively deploying shadow resources next to the live ones. So no issues with drift. It's operationally very convenient. And we had real environment accuracy, but we were testing features within the production, but not the production itself. We had a limited ability to test infrastructure changes. In particular, Kubernetes upgrades, version upgrades were difficult. And the side effect, our clusters became too special, and we were treating it as a pet and not as a kettle. So our key takeaway was shadow testing solved our immediate problem, but concealed systemic fragility in our infrastructure. When we started to work on a new platform based on Kubernetes, we learned from past mistakes. And we decided, well, we want to have truly repeatable clusters, and we want separate test environments. That is a simplified version of our initial setup. We use EKS and have a production AWS account with production and non-production clusters for our delivery teams. And also, we have a platform dev environment for platform engineers in a separate account. Before we move forward, it is important to say that this dev environment is internal to our platform team, and we are not talking about scale here. All clusters are deployed from same infrastructure as code templates. We are using Terraform to deploy the entire stack, EKS clusters, AWS infrastructure, all platform-related components within the clusters, and infrastructure as code files are stored in Git in a single repository. For the platform, we use push CI/CD model, and well, Gazal will talk about ArgoCD a bit later. Our CI/CD pipeline has a step to apply our Terraform configuration. So effectively, we have returned to a long-lived test environment approach. And that lasted for about a week before it became unstable. Not very long-lived, it turned out. Our platform in an active development phase, and for rapid innovation, we need to experiment freely. And platform engineers need to evaluate different and sometimes conflicting options without disrupting each other's work. That single EKS cluster became a bottleneck. So we decided we need resettable environments. How often do you want to reset it? Weekly, daily, ideally for every task. That's when we realized, okay, we have infrastructure as code files, and we can deploy as many clusters as we want. And if you want to do it for every branch of our Terraform configuration, we can do it. It is workflow of our initial implementation. When you create a branch on that Terraform configuration Git repo and push it, CI/CD pipeline has a step to calculate the name of EKS cluster. Name is based on the branch. Terraform apply step will create a cluster and pause. Cluster name and details will be published, and you can go and experiment with a new cluster, or you can make changes, push your changes. CI/CD pipeline will kick off another build, will apply your changes, and you will have your EKS cluster with changes applied. You might run a few cycles there, and when you are done, you unpause that CI/CD pipeline. And the next step would be to destroy that EKS cluster. And that worked really well for a few days, until we discovered that we created a cluster to fix documentation typo, which is a bit of overkill. So that's our next iteration. We have implemented a conditional cluster creation. When a new branch is created, engineers are expected to push a special empty commit with a message branch cluster. CI pipeline creates a new development cluster only when it found that commit. No more clusters for fixing documentation typos. It is a screenshot of our pipeline. We can see step checking condition. It will trigger branch cluster creation. There is apply Terraform step at the bottom, followed by the pause. And then after the pause, you can see a grayed out destroy step. We have a few challenges with that implementation. First of all, our Git repository with Terraform configuration is becoming a little bit too big for our liking. We are thinking about how we can split it. We are managing additional costs as well, comparing to a shared environment. But again, we are not talking about 1,000 clusters. We are talking about internal to platform team clusters. So usually clusters are in single digits. We have quite complex CI/CD pipeline configuration with conditional steps, with pause. In technical sense, probably the most difficult step turned out to be cleaning up correctly. Terraform destroy step turned out to be quite difficult to get all the dependencies right, to make sure that all the AWS resources are cleaned up correctly, and so on. Also, there is a human component to it. So we rely on people to press that pause button when they are done with experimenting, and to make sure that we remove those clusters when people don't need it. We do Friday reminders. The last one is about multi-cluster architecture. So we are moving towards multi-cluster architecture, and we don't know yet what it means for our dev clusters. It's something for us to figure out. So implementation is constantly changing as we move forward. But the concept of those ephemeral clusters is simply addictive. As platform engineers, we love to be able to get a clean, up-to-date copy of production entirely for ourselves. It gives us freedom to experiment and move faster. And as I mentioned, these ephemeral test clusters are internal to our platform team. So what about our platform customers, RA developers?
That's where I step in. Thank you, Tatiana, for walking us through the power of ephemeral EKS clusters. Of course, the concept of ephemeral environments is also essential for our first-party applications, what we call REA systems. I'm going to dive into how we create dynamic preview environments for our applications using ArgoCD. So this is about taking the benefits of ephemeral infrastructure right down to the developer's daily workflow. So let's be honest, we've all been there. Even with mature IAC, long-lived shared test environments introduce a unique set of headaches. First, resource contention. You want to test a change you made to a system, but you realize someone else is already using the shared test environment. This leads directly to interference and unreliable tests. Even with our clear domain boundaries at REA, if Team A deploys a new version of a shared library, it can unintentionally break Team B's tests, leading to flaky results that are incredibly frustrating to debug. This is a common pain point, even in mature microservice architectures, especially in areas like backend for frontends, where multiple teams might contribute or consume. These issues inevitably lead to complex debugging and reproducibility. When a test fails in a shared environment, it's often incredibly difficult to pinpoint the exact cause or reliably reproduce the issue because the environment state might have changed due to another team's activity or lingering side effects. This significantly slows down our ability to fix issues and deliver features. And finally, inefficiency and cost related to fixed schedules. At REA, we've long had scheduled downtime for our non-production environments to save costs, often letting them be unavailable outside Melbourne business hours. While this was a good step with our expanding global teams, particularly with our CyberCity Gurugram office, these fixed schedules now create significant productivity bottlenecks. So teams in different time zones are blocked from working, leading to delays. So what is the alternative? The modern approach and what we are embracing at REA is dynamic preview environments. Imagine a world where every pull request gets its own isolated production-like environment. The concept is simple. When you open a PR, an environment is spun up specifically for that change. You automatically, so you can test, you validate, and you get immediate feedback. Once the PR is merged or closed, that environment is automatically turned down. It's truly on-demand and ephemeral. This brings true isolation, rapid validation, and ensures your testing is always against a production-like state. It's a fundamental shift that aligns perfectly with GitOps principles and the agility demanded by cloud-native development. So how do we make this vision a reality? Our primary tool is ArgoCD. Specifically, it's application set controller and the pull request generator. The application set allows us to define a pattern for applications. The pull request generator then monitors our GitHub repositories. When a new PR is opened, it dynamically generates an ArgoCD application resource, effectively telling ArgoCD to deploy the specific PR's branch. To keep namespace provisioning and associated access simple, we use a single namespace for each system, but the entire set of resources for the application has a PR number suffix to ensure segregation. A crucial piece for us is label filtering. We don't want a preview environment for every single PR, especially automated ones like Renovate bot updates. So we configure it to only create environments for PRs that have a specific label like preview, which devs can add when they need it. For the best dev experience, we also integrate a GitHub webhook. This means ArgoCD doesn't have to constantly poll GitHub. It gets instant notifications when a PR is opened, updated, or closed, triggering the environment creation or destruction in near real time. So let's see this in action. The best way to understand the power of dynamic environments is to witness their speed and efficiency. Now, it's not going to be a live demo because we're not that brave. It's a screen recording. So I'll step through the screen recording and walk you through what is happening. Hold on. So, yeah, here I have a new pull request. I've made a simple change to the diagnostic version endpoint for the system. Now let's add the preview label to the PR, and we'll go over to ArgoCD UI and notice how quickly ArgoCD detects this change. Okay. You can see a new ArgoCD application resource appearing, named after the PR, and it immediately starts syncing. We'll wait a bit for the pods to get ready. Sometimes the data plane takes a little bit of time, of course, to scale up. Once that is ready, we'll check the HTTP route resource, part of the gateway API, to find the host name for the system to verify it. But I am waiting. OK, HTTP route. I'll get the host name, copy that. Now, I also like to ensure that the Route 53 records for the system have been created before hitting the endpoint, so I'll check the external DNS logs. So it looks good. I'll hit the diagnostic version endpoint to verify the change we made. And there we go. If you can see towards the very left there, it says preview 1. Let me hit pause right there. So there you have it. You see a test environment, a dynamic test environment gets created, and that has the change that we made in the PR. Now, let's go to a different PR to illustrate the true benefit of dynamic preview environments. Imagine having 5, 10, or even 20 active PRs. Each one gets its own dedicated, isolated environment. No more waiting, no more interference. This is the scalability of ephemeral test environments. So I'll go to the other PR, and it's got a very similar change. This time it's just preview 2. Easy. And we'll, again, add the preview label to it. And we'll go over to ArgoCD. And just like before, a new preview environment has started to sync. Again, we'll get the host name for this one, the unique host name. We'll copy that. Just double check on external DNS if it has been provisioned. Now we hit the diagnostic version endpoint for the new preview environment. And there you have it, another preview. As easy as that. Now let's go to, Now we'll look at the cleanup process. There are a few ways to remove a dynamic preview environment. The first one, we could just be done with this particular dynamic preview environment, so we remove the preview label. And you can see on the right side, ArgoCD immediately detects that change and starts deleting the application. Another option is we could merge or close a PR. Since this is a test change that I don't intend on merging, I'll just close the PR. And again, ArgoCD starts deleting. So when a PR is merged or closed, or when the preview label is removed, ArgoCD automatically detects this change and initiates a teardown. You'll eventually see the application resource disappear, and all associated Kubernetes resources are cleaned up. It's efficient, it's automatic, and it saves resources. So what are the tangible benefits we've realized from adopting dynamic preview environments? First, increased agility. Our dev teams can iterate much faster, getting immediate feedback on their changes without waiting for shared resources. Crucially, minimized interference and maximized reliability by providing true isolation for each PR. We eliminate the flaky test syndrome caused by shared state or concurrent deployments. We see optimized resource usage. Environments only exist when they're actively needed for testing, leading cost savings compared to always-on, underutilized shared environments. The dev experience is greatly enhanced. It's a self-service model. Devs get immediate actionable feedback directly tied to their PRs empowering them to move faster. And finally, this all leads to improved quality. More thorough and reliable testing in isolated production-like conditions mean fewer surprises when code hits production. This is a powerful pattern that we believe is key to modern software delivery. That's us. Thank you. And yes, we are hiring in the REA CyberCity office. There's a QR code. And open to any questions. Can you say that again? So, we'll be honest, we haven't exactly done the math. This hasn't been scaled to the entire org yet. But what we have noticed is a lot of our systems, they don't even have preview environments all the time. So compared to a shared test environment, it does save cost. So once in a while, when a PR actually needs a shared test environment, that's the only time that it is running. Sorry, did I say shared? I meant a dynamic preview environment.
How you guys manage like other components where database or Redis or RabbitMQ I need within working service. So how you guys manage with this ephemeral environments?
Yeah. So we've primarily applied this to our stateless backend sort of services, where you don't have to deal with a lot of state. But we did also solve it for one of our Flink deployments, where a lot of this state for it, save points, checkpoints, they're all in some kind of object storage. So on AWS, it's S3 buckets. So what we did do was, instead of creating a separate S3 bucket for each dynamic preview environment, we just added prefixes to segregate between each of them. We haven't fully realized a solution for RDBMSs and such, but we have observed that modern data backends do scale better to this pattern. Like if it's like an Iceberg data lake or something, they already have that capability of a separate version for the data lake itself.
Okay, so this means that, okay, it's kind of a shared resource between multiple ephemeral environments where they can share between and still these things works, right?
Not quite. So for the Flink deployments, the state backends are indeed separate between each dynamic preview environment. It's just that we have to make, I think, the balanced choice on where you apply the segregation. Could we have created a separate S3 bucket for each one? Potentially, but instead of that complexity, we went for prefixes which give the same level of segregation, but without the complexity.
And this applicable same like when we go on a production, because see, that's what we want to achieve over here, to match with production as much as possible.
Yes.
Yes.
So yes, the whole idea with these dynamic ephemeral environments is that it is a production-like state. So even in production, you still have an S3 bucket, you still tell which prefix you need to put the state in. So in that sense, it is the same.
Thank you.
Hey Gazal, right here, Suraj here.
Hi.
So my question goes to, so right now, this is something which is applicable for like a single application you have currently in place. What about, I have like 5 different microservices which is spreading across different repositories, like just for an example, user management service or the key management service, or like 5 different services at the same time. And that each and every service has a change that I need to test, and that has to go to production. So how can I test this together?
I think you might be asking for some kind of an end-to-end test environment where you have...
So similar to that, yes.
Sure. So philosophically at REA Group, we try to avoid that as much as possible. We have test environments for each system, but we try to avoid having end-to-end test environments. We've seen that having those brings with it its own set of complexities. So most of our test environments for, say, our listings experience API or something, if it has to connect with another system, it might be the production system equivalent of that. So I don't know if I can answer your question about an end-to-end test environment. Apologies.
Well, I get it. So I would like to share one more thing because, I also implemented kind of a similar thing for one of my organization. And so instead of so just because we were having multiple services in place and that needs to have a kind of a end-to-end testing with all those changes in. So instead of doing at a particular service level, we did at a repo which actually stores a production level Helm charts.
Yep.
Don't worry, it's not gonna directly merge to master branch.
Yeah.
Instead of that, it will create again, same thing, it goes to PR, it will accept all those testing parameters, and it will have that preview environment ready. Again, same thing, dynamic DNS, everything. And just to answer the previous question, just kind of addition to that. So just to have a separate database, because I don't want to mess up production database at all. So just to have a separate database, initially we tried writing something like very customized, just like writing a script which will take the dump, just add very small entry of it into that preview database, create a copy of it, attach to that test environment, and it will be ready for your use case.
Yeah.
Later, we found there is one, even a tool, since we are using Postgres flavor of it, there is a tool which will even support a database versioning as well. I don't remember at the moment, but that will help you a lot for that purpose.
Perfect. Thank you for that.
Thank you so much.
Hi, I have a question. So when these tests are done and when you do a preview on a PR, how are you reporting it back? Do you have an observability stack or a log stash somewhere which users can go to?
Yeah.
Or does the report come back to in a PR as comment? Like how are you managing that piece?
So when we talk about automated tests for each of the preview environments, that's, again, not something that we've implemented as of yet. But to answer your second question about observability, so observability in general is something that we've added to the whole non-production cluster. So for each of these preview environments, they appear as separate OTel services in our observability dashboards.
Is there also some form of reporting back to the PR? Like, do you have commit status which will block the PR if, let's say, the test failed or something like that?
Not at the moment, but absolutely on our wish list. Thank you for the question.
Yeah, one question here.
Did you want to add?
No, I think we are at time.
Yeah, I have a question.
Yeah, one last question.
One last question.
I have a question.
So this
are
is
you
regarding
using-
the CR and CRDs. So like assume you created, question here.
Okay.
So assume you created the entire test application, right, through CRs created. So like some CRs are namespace specific or some are cluster scoped. So what happens to the cluster scope resources that was created?
Well, if you're referring, if I understand correctly, you are referring to our
So always with a
input
brand.
CRD dash next resources. Is that correct?
Yeah. So when you create a branch, right? So along
Yeah.
with CRs also created custom resources, and those
Yes.
are like cluster scoped. But along in the same cluster, there will be multiple branches, multiple
Yep,
environments
yep,
get created.
yep. So we are adding dash next not to resources themselves, but to CRD. So we are generating another CRD with dash next name. And it will work equally well for cluster scoped and namespace scoped.
So if I understood correct, so for each environment, the CR name is also unique.
Yes, yes.
That-
So it is next dash next CRD.
Thank you.
Yeah, one question. Like you mentioned, in the CI step, we do a pause.
Yes.
And in that pause, the responsibility of the developer is to verify whether the environment is working or correct or not. Let's say I am a developer. I verified my environment is working correct. But I didn't continue the pipeline. Okay?
Yes.
And of course, I will get Friday reminders, but I ignored them. Okay? So is there any provision of default timeout? Like after n hours, the infra will automatically be deprovisioned, whether I do something or not.
If we are scaling it up to a bigger team, we will absolutely need it. But for the current platform team, no. We will publish the reminders, and we know who is responsible for each cluster, and we just talk on a human level.
Okay, okay. Thank you.
Oh, can,
So on every commit, you keep redeploying the services, or how does it happen?
is this about the, what is that, for the clusters or for the dev environments?
It's a PR, right?
Yeah,
I'm
could-
talking about a PR.
Could you
So
please?
I created a PR and I added a preview label, and your environment is up and running.
Sure.
Now I got a review comment from my code, peers,
Yep.
and I updated my PR. A new commit got pushed.
Yep.
So automatically ArgoCD takes up, because I see you are using charts, and whenever a new commit get pushed, maybe the charts, the version you are updating in the charts label or a YAML file.
Yeah.
But when a new PR gets added, which is related to something related to application code, charts file is not getting updated, and your ArgoCD application project set might not redeploy. So how are you taking care of those things?
Sure, sure. So ArgoCD itself, the way pull request generator works is you can sort of point it to where a chart is, and how we'd set this up is the image tag is referenced from the build output itself. So I can't bring up the exact YAML spec, but I could have shown you how it reads the commit hash that's latest on the PR. So if you make an amendment, that container version is what gets picked up.
So underlying CI pipeline creates a new container and pushes it to the repository, and ArgoCD picks up from the repository.
Exactly.
Okay, thank you.
Thank you.
And underlying thing is fully Helm based. Helm charts are the ones that you are using.
Yes, yes.
Okay, thank you.
Okay. I think we are definitely at time.
Yep.
And thank you, everyone, and thank you for your questions.
Thank you.